All right, so hi everyone, and welcome to another FAME webinar in our series. My name is Mariana Jaralambus. I'm a project manager at INNOV. We're happy to welcome you to today's session that is titled From Code to Clarity, Understanding Data Assets Through Smart Contracts. A few words on the FAME project that is funded by the European Union under Horizon Europe. The project brings together experts in data management, digital finance, and the data economy with the goal to build a secure, trustworthy, and energy efficient data marketplace for embedded finance. We have run a series of webinars, which you can find on our YouTube channel. Before we get started with today's session, just a couple of housekeeping notes that the webinar is being recorded and it will be available on our YouTube channel in a couple of days. Feel free to type any questions you may have in the Q&A box, or after the presentation, you can just unmute yourself and ask any questions you may have. So without further ado, Marios, the floor is yours.
Right. Thank you, Mariana. So welcome all. Good afternoon. So before I start, just let me, if you can see my screen and if everything works as expected. Yes. So you see my PowerPoint?
Yes.
Okay.
We can see.
Excellent. So good afternoon. Thank you for joining today's session for this famous webinar. And for the ones that do not know me, my name is Touloupos. I'm a senior researcher and software engineer at INNOV. Also, I'm a postdoc researcher at the Cyprus University of Technology. And today we're gonna explore basically how blockchain and smart contracts can redefine the way we understand and manage the data assets. So that's why the title of the presentation, as you can see, is From Code to Clarity, Understanding Data Assets Through Smart Contracts. What I will try to achieve in this session is basically to connect your technical understanding with some practical applications. And in doing so, I will try to unpack and discuss about the challenges around data ownership and trust. And then I will also explain how blockchain provides the foundation for verifiable governance and how also smart contracts turn those principles into executable logic. Right, so today's journey, as I used to name it, we'll start by defining the data asset problem. We'll see why data, and despite being one of the world's most valuable resources, still suffer from unclear ownership and governance. Then we will discuss blockchain as a trust infrastructure. We'll explain how distributed ledgers introduce transparency and accountability into data ecosystems. Then we'll go into smart contract foundations. We'll see how ownership, how access and licensing rules can be encoded directly into code. After that, we'll move into a live demo where I will basically build and deploy a simple smart contract from scratch using Remix and Online ID. And finally, I will conclude with some discussion on future challenges, specifically privacy, interoperability, and some other hybrid architectures that they connect on-chain and off-chain systems. So let's start with the big picture. So in the digital economy, data is an asset class. So it fuels AI models. It used to drive analytics, but also create enormous economic value. However, most of the time we can't basically clearly answer three simple questions. First of all, we cannot clearly answer who owns the data. Secondly, how are these data being used? And finally, who actually benefits from this data? Current systems are built on some opaque agreements and centralized platforms. The ownership is often hidden inside legal documents that nobody actually reads. In terms of provenance, meaning that the origin and lineage of data is rarely verifiable, and usage of course, are enforced through trust and not through technology. So as a result, we operate in an environment full of friction, but also distrust. So organizations hesitate to share their data, individuals lose control of their personal information, and value distribution becomes inefficient. So what is the core problem now? Let's summarize the problem into four main points, as you can see. So first, there is the opacity of ownership. So we have no consistent way to verify who created the dataset or how the ownership changed over the time. Secondly, there is a lack of traceability. I mean, once data leaves its origin, it's nearly impossible to track where it goes or how it's being used. Third, we have the trust gaps, intermediaries. So platforms, brokers, or some other large organizations, they control their access and the licensing stuff. So everyone must trust them, yet they often operate behind closed systems, as you know. And finally, inefficient value distribution. The people basically who contribute or create data rarely get compensated fairly because we can't link contribution to usage in a verifiable way. Now, how code can bring the so-called clarity. So here's where basically smart contracts enter the game and the picture. So instead of relying solely on legal documents or centralized enforcement, we can encode some rules to define ownership, to define access, and also revenue sharing directly into some executable code written and deployed on the blockchain. So what does that mean? It means that the rules are transparent, they are automatic, and of course verifiable by all parties. So we move from trust me to verify yourself. And also once we define the logic in the code, we no longer depend on intermediaries to enforce agreements, but the blockchain enforce them. Now, what are the data assets? So what exactly is a data asset? In simple terms, a data asset is any piece of structure, but maybe unstructured data that carries economic value. That could be either a data set, a trained machine learning model, a research result, a digital artwork, something that a user, the so-called user-generated content that we often have nowadays. So every data asset typically includes metadata describing what it contains, describe provenance information, shows where it came from. It shows also some licensing terms, specifying who can use it and how. It gives access controls, limiting the visibility of the usage, but also sometimes it offers valuation models defining how it's priced. Now, let's see the blockchain aspect. So blockchain would work as a trust layer, as we say. So blockchain basically provides exactly the kind of infrastructure that we need to manage those digital rights that we have discussed. At its core, of course, blockchain is an immutable distributed ledger. It gives us a single source of truth that's verified collectively rather than owned by any single party. And there are 4 core properties that make it useful, as you can see here. So start off with the very first one is the immutability aspect. So it means that once recorded, data cannot be changed without consensus. We have also the transparency aspect, meaning that every transaction is visible and auditable. We have decentralization, where control is basically distributed, reducing single point of failures, of course. And then we have some cryptographic security, where we know that ownership is tied to digital signatures and thus making it mathematically verifiable. Now, here is the smart contracts aspect and how this is getting into play. Traditional contracts are basically written on legal language and depend on lawyers, courts, or intermediaries to interpret and enforce them. But now smart contracts are different. So they are basically self-executing programs that are stored after they are deployed on the blockchain. Their conditions are unambiguous. So when predefined criteria are met, we have some actions that are executed automatically. And that means less ambiguity, no manual enforcement, and of course, guaranteed execution as long as the network exists. So anyone can verify that the contract did exactly what it was supposed to do without having to trust an intermediary. Now, so how do we apply smart contracts to govern the data? We can encode 4 major elements. On top left, you can see the ownership rights. We can define who owns the asset and how ownership is being transferred. So every transaction is signed and permanently recorded. Then we can define access control mechanism. We can define who can view, who can use or modify data, possibly based on some time limits or some payment conditions. We can define licensing terms specifying usage rules, attribution, or even restrictions automatically enforced by the contract logic. And finally, we can define the revenue distribution, splitting payments among creators or contributors in real time according to some predefined percentages. So now let's see how are these being done in terms of some more technical aspects. So let's see in this slide how these digital assets can be represented. Ethereum, if we talk about the Ethereum, has some standardized token formats that basically let different applications to interoperate. So 2 of them are particularly relevant here. So first one is ERC-721, which is the non-fungible token standard that represents unique assets. So each token has its own identifier and metadata, and that's why it's the perfect fit for one-of-a-kind dataset or maybe a proprietary model. The next one is ERC 1155, the multi-token standard that allows both unique and fungible tokens under one contract. So that's kind of more flexible. And for example, a dataset might have multiple copies with tiered access rights or license durations. Now, let's see where these ideas are already being used. So we can discuss about the Ocean Protocol if you are aware of it. So this protocol provides basically a decentralized data marketplace where owners can monetize their data securely. Instead of sharing raw datasets, algorithms run directly where the data resides. So that ensures the privacy through compute to data mechanisms. We have another protocol which is Gaia-X, a European initiative which builds sovereign data spaces that connect organizations across borders using blockchain for verifiable trust. And in academic research, we have tokenized data assets that are being used to reward researchers for sharing their work. So each time, basically, their dataset contributes to a downstream study, they receive some automatic credit or some compensation, if we may say. Now we arrive to the place where we will have a small live demo, and this is where I will dive into Remix ID. I guess Mariana later will share also the presentation, right? We can share it with the participants.
Yes, of course. We will upload it on our learning center. Yes.
Okay, because I also give some instructions on how to execute the demo yourselves if you are interested. So I'm sharing also some code, etc. So there are a couple of slides here. So yes, just let me share my browser now instead. Okay, do you see my browser?
We can see it.
Yes.
The Remix. Yes.
Yeah, the Remix. Is it clear?
I see it clearly. Yeah, it looks good.
Okay. All right. Just a minute. Let me make sure I have everything.
Oh, yeah.
In the right
Dimitri
place.
says if you can increase the resolution, Maria.
Yes.
Okay.
The resolution.
Great. Yeah, that's a comment from Dimitris.
I will try to zoom a bit more.
Yeah.
Okay. All right. So here you can see I have a Solidity file, which is where we have the code for our contract, smart contract, right? We have a class named data asset. This is where we define our class, what they are, what this data asset is consisted of. And as you can see, each asset will be represented by a structure containing a name and description, a metadata URI, the owner address, the price, if it is available or not, and also a created ad, which is a timestamp showing when the asset was basically created. Now the contract also, if I scroll a bit down, defines 3 events for transparency purposes. So we have the asset created, which is triggered when a new data asset is registered. We have the asset transferred, which is an event triggered when ownership of an asset changes. And also we have the access granted, which is triggered when someone buys access of the asset. Now, the create asset function allows anyone to register a new asset. So it automatically increments the asset counter, as you can see here, line 30, right? Stores the new asset on chain, assigns ownership to the caller, and also emits an asset created event. Next, we have the transfer ownership function, which lets the current owner give the asset to another address. It includes checks to ensure that only the owner can initiate the transfer, that the new owner is a valid address. And once completed, the asset transfer event is recorded, making the handover transparent. Then line 70, we have function purchase access, which basically handles the monetization of the asset. Anyone can call this function and pay the required amount in order to gain access to that asset. The function checks that the asset is available, of course, that the payment meets the price, and that the user has not already bought access. Then we have some other helper functions, the has access function, that lets anyone verify whether a user is authorized to use a specific asset or not. And basically that's pretty much everything. So now that I have gone through the code, the next thing I need to do is basically compile my contract. Okay, so this is automatically done, but let me just hit compile data asset.sol, which is this will trigger the compilation of my code, my smart contract. And once I have this successfully executed, I need to go on to the this tab here, where is the deploy and run transactions. And this is where I will actually deploy my smart contract. So here I can choose the environment. Here I can use, for example, through my MetaMask wallet, where I could a priori define and connect to my private network or to a public blockchain network as well. But in this case, we're going to use some environments provided directly from Remix, for example, a Remix VM Prague, which is a simulated environment, and it gives us some accounts to work with, and so on and so forth. So I have used one blockchain network that is provided by Remix itself, and also the first account that, again, is being given by Remix. Now, hitting the deploy button, I'm going to deploy my contract, but let me fix a bit my screen in order for you to see. Just a minute. Here it is. You see that this is the transaction. It says that the contract was successfully deployed with some metadata about the contract. Now that my contract is being deployed, I can see it here, and I can also here see the hash that it received after was deployed on that specific blockchain. So by opening the tab of that contract, I can see that here are all the functions that I have described before. So you can see that I have the create asset, the purchase access, transfer ownership, access grants, asset count, assets, and has access. So here now that because I haven't created any asset yet, by clicking asset count, I can see that currently I have 0 assets defined. So let's go and create our first data asset. So here you can see that the create asset, it expects a name in string format and description, metadata URI, and the price. So I have prepared before, and here I've defined name as my data set, description, temperature data from sensors, a URI. This could be an IPFS URI where my data set would be stored, and also a price which is in way, and that translates into 0.01 ethers. So by clicking create asset, you can see that I have created my asset and its data are stored on chain, and here they are. So clicking asset count, you can see that now I have one asset registered. Here I can check if I have access. For example, I can give the asset ID plus comma, sorry, my wallet hash, which I can copy from here, and if I can paste it here, has access, I get true. In theory, if I choose another account hash, if everything was successful, I should get a false, which I get. So the second account that I have used, this wallet here, has no access on this data asset. Same thing I can do with the transfer ownership. I can define the asset ID and the new hash of the wallet for the new owner and execute to transfer the ownership, and so on and so forth. So that's pretty much everything about how I can write and deploy a simple contract for managing my data assets. Do you have any questions so far, or shall I move on? Shall I go back to the presentation? We have a couple of slides more. I don't see if anyone is raising its hand. Mariana?
No one is raising the hand, so I guess we can go to the
okay,
the presentation.
Just a minute. Okay, now can you see the presentation again?
Yes, we can see it.
Right. So let me go to the... Right, here we are. Right, so what did we just see? So we saw verifiable ownership, where every asset and transaction is publicly traceable. We saw transparency with events that make every state change auditable. We saw automated enforcement, where the code guarantees that rules are applied exactly as written. And finally, we saw direct value capture with payments going straight to the creators, and with no middlemen, no delays, and no other settlement overhead. Of course, some challenges still remain. So privacy is the first. Public blockchains expose, if I may say, transaction data. So handling sensitive data sets require complementary technologies like zero knowledge proofs, secure enclaves, or hybrid on-chain, off-chain approaches. Second thing is interoperability, of course. So different blockchain ecosystems don't always talk to each other easily. So cross-chain breaches and standardized data schemas are still maturing. Third, we have the scalability. So storing large data sets directly on chain is impractical, and expensive. So instead, we store metadata on chain and we keep the data itself in other decentralized storages, such as IPFS or Arwave, etc. And finally, it's about legal ambiguity. So basically, smart contract ownership doesn't always translate to recognized legal ownership, if not never. And regulators are basically still defining, if I may say, how blockchain-based property rights fit within existing laws. Now, looking ahead, several trends will shape this space, of course. So we will see hybrid architectures that will combine blockchain's trust layer with off-chain computation. For example, contracts can manage rights and payments while the heavy data processing happens securely somewhere else. Cross-chain interoperability is another frontier. So projects like Polkadot, Cosmos, and Layer Zero are building standards that allow assets and data to move seamlessly across blockchains. And of course, privacy preserving technologies such as zero knowledge proofs and homomorphic encryption will allow computations or encrypting data without ever revealing the raw content, so opening the door for privacy compliant data markets. These are the directions where research, also innovation, and regulation need to be converged, in my point of view. But I'm open to further discuss with you if you consider anything else. Now, let's summarize the essence of today's session. So first of all, smart contracts turn abstract rights into executable rules. They remove ambiguity and automate trust. Second, blockchain provides the trust infrastructure that ensures every record is both verifiable and immutable. Third, we have seen token standards like ERC 721 and ERC 1155 that both make assets portable and interoperable, enabling data marketplaces and decentralized licensing, and so on and so forth. And okay, some recommended resources for you to take a look. And yeah, basically here I have some questions and discussion. So I would like to open the floor for questions. So feel free to ask about anything that you find interesting or yeah.
Thank you very much, Mari. That was a very interesting presentation about the smart contracts and how they work. So we are open to discussion, and any questions you may have, you can just unmute your mic or use the chat. Okay, I can. Yes, please, Xin, you can go ahead.
Okay, yeah, first of all, thank you very much for the great presentation and for the great achievement for the project, because this is really very valuable contribution to integrate the blockchain technology into the IDS, the data space architectures. And I read your technical architecture design, and I see you have adopted the IDS reference architecture, right? into your architecture design, and also some Gaia-X, GX, FS services. Could you maybe introduce a little more about it? It's about the challenges. Is if this integration, is if it's seamless, or do you have some challenges?
Thank you, Jean. Thank you very much for your comments. Yeah. Basically, your question is about these projects here, right? So
Yeah. Mm-hmm.
Okay, so these are some real world applications, and where we've seen where real data assets stuff on blockchain are taking place. So an example is again the Ocean Protocol and Gaia-X. So Gaia-X is a European initiative. Is a European Federation of Data Infrastructure Providers that create sovereign interoperable data spaces with blockchain-based trust. And also the Ocean Protocol, which I have studied, to be honest, and I have seen that they did a really nice job into that stuff in order to monetize data assets and provide different APIs and applications to use if you are either a developer or a researcher or any individual that you are interested to create maybe a store or something to share your real data assets. So I don't know if I've covered your question.
No, actually, in the Gaia-X is an association, and the Gaia-X deliverable is the Gaia-X trust framework for distributed identity management, and also very important is the Gaia-X digital clearinghouse. This is for the automated compliance evaluation engine. Yeah, this is for the whole ecosystem. For example, if later on the FAME marketplace, and if you onboarding your participants, companies, and to implement the interoperability with other ecosystem data space, and you really need the Gaia-X digital clearinghouse to do this compliance checking. Yeah, but in the Gaia-X there is one major data space ecosystem and consortium named Pontus X. This Pontus X really implement based the Ocean Protocol. Yeah, this is currently the single besides FAME. Yeah, the single blockchain technology based data space implementation, and they really implement the Ocean Protocol and also adopted they don't use the token as you're used. They use the token euro as the stablecoin named the euro stablecoin for monetization. I don't know if you are familiar with this. Is from the German company developed the real stablecoin.
No, to be honest, I'm not really familiar with that. And also in regards to the main FAME technology, so now I think we don't have any technical someone from the technical team that developed that specific aspect in the FAME project. So I cannot clearly answer your question, but of course we can. You can give us your email, and we can give you a reply through an email from some technical partner that is better to give you a concrete and clear answer, because I don't want to give any false information.
Yeah,
absolutely. I also put my email in the chat, so you can email me directly and get you in touch with the technical team.
Thank you very much. We will exchange our contact data. And the next question, because my first question, yeah, because there are two major associations. One is Gaia-X, another is the International Data Space Association, the IDSA. I don't know if your team or your consortium, yeah, is any member of the both one or not.
A member of the International Space Association in the consortium.
IDSA, yeah, IDSA.
Yeah, it is a part of the consortium, yeah. But we have no one from the team is attending the webinar right now.
Yeah, actually, I really recommend maybe you could introduce your it's very excellent project in the IDSA ecosystem call, because in the IDSA every week we have the member ecosystem, and every member could introduce their project, their data space project is to the all members. This is, I think, your project is really have the valuable development, and it's very because could help the current the other companies and the research institute to understand how to integrate the blockchain into the data space, because it's currently they all just implement the data space protocol using the data space connector, but it's how to monetize the whole things and to implement the marketplace, they don't have idea. So that is my recommendation. This is
No, I mean, we are happy to get you in direct contact with someone from the International Space Association. We also have some upcoming webinars that the speakers will be from the. So I can send you all the details for the upcoming webinars as well. So you can that will be more focused on your questions.
Okay. Yeah. Thank you. Thank you very much.
Thank you very much for the discussion and the participation.
Yeah.
All right. Are there any other comments or question? Let's see the chat. We have awesome. We have shared the email addresses, so feel free to reach out for anything additional. So if there are no, yes, Dimitri.
So thank you very much for the presentation. For me, it's first time because my experience is not exactly code-based. Rather, I have a business-focused background. And my question is the following, that we have created a smart contract, okay, and we have used Remix. So question number one, is this smart contract now operational? Is it running?
Yes, short answer, yes, but
Okay.
it's operational on the simulated environment of Remix. So you cannot connect to that blockchain out from the Remix and interact with that blockchain. That's a simulated environment. And basically, once I close my browser tab, this will basically vanish, and I need to re-execute and redeploy the contract. So, but in the meantime, yeah, for the moment, yes, it is.
So under an ideal environment, we have created a smart contract starting 0x, blah blah blah. So what would happen if I would like to look up this smart contract and the process? Okay, I have a smart contract and I would like to see, I know nothing about it, and I would like to explore to see what it does. Perhaps you can, if that's easy, you can use something similar to show us how this is done.
Yes, if I got your question right, so here is the following. I have written the code of the smart contract, right? So that's Solidity, okay?
Yes.
Plain Solidity, it's code. Once I compile the Solidity version of the contract, I will get back two things. I will get the bytecode, which is what the EVM understands. It's not human readable, it's just 0 and 1s, and it's compiler, it's the low level language that compilers understand, as we used to have in assembly, and we used to have in assembly code, etc., if you are aware. And also, I will get the ABI ABI is basically a JSON schema that translates, and a human can see and read and understand what that smart contract can do. So it describes the functions that the contract provides, what arguments the functions get, and what they give as an output. So if I want to give my contract to someone else to interact with it, I need to give that ABI to him as well, so he knows what that contract does. Unless he can go on and find using the contract address through Etherscan, for example, and use the hash, retrieve the contract, and then access its functions and see what it can do in order to know how to interact with the ladder. So I've tried to briefly explain the whole process. I don't know if I was clear.
Yeah, thank you. Thank you. So for the non-technical as I am, if I go to a blockchain explorer, Etherscan, for example, and input the contract number, I would be able at some point to, if I have the
Yes.
knowledge, to drill down and see what this smart contract does exactly.
Yes, that's right.
Accurate?
Yes.
Yeah. Okay. Thank you. Thank you. Thank you very much.
You're welcome.
Thank you, Dimitri. Okay. Any other comments or questions? If not, we can wrap it up. Mario, thank you very much for the presentation.
My pleasure.
As I've mentioned at the beginning, we will upload it on our YouTube channel and our Learning Center, along with the presentation. Thank you, everyone, for attending. So have a nice rest of the day. Bye, everyone.
Okay, thank you very much. Bye-bye.
Thank you.
Thank you.
Bye-bye. Have a nice afternoon.
Thank you.
Bye-bye.